multiple choice. And again, there's already a video posted. It's only missing like 3 problems. Okay? Yep. All right. Boot camp. Getting ready for the test. All right. Oh, for some reason I only have the magnitude on this one. All right. So we're not going to worry about the direction angle. Let's just do the magnitude, okay? So the magnitude. It says find the magnitude and the direction angle of forms with the positive x-axis for the vector. So we basically, for the magnitude, we take and square these two values, the x component and the y component. So it's the square root of negative square root of 2 squared plus the square root of 2 squared.
Wait, but can you find the direction after you find the
Sure.
Hey, is the study guide this week's homework?
It was last week's homework, was it? Or part of this week's, I can't remember.
It's Monday and Tuesday.
All right. So this would be 2 plus 2, right? 2 plus 2 is 4, and the square root of 4 is 2. Don't circle your answer. No. Because when you square it, the negative goes away. All right. I'm not going to mess with the direction angle, okay? It won't be on the test. All right. What else do you guys want to talk about?
Number 2.
Okay. Yeah, remember the formula. You've got some formulas on this one, so you want to make sure you know all of those. No. Okay. All right. We need to find the component form of the vector, okay? So remember, this is the way I think about it. You've got the cosine, comma, the sine for unit circle, right? So the component form of the vector is you take whatever the value is, and that goes in front, okay? Then this one is, the x is cosine, the y is sine, and then you put your degree measure in the back. And that's it. That's your component form. That's all you do. Okay? What? Can I do a lot of those ones? There might be one. All right, we good with number 2? Okay, number 3.
Someone said no.
No, I'm sorry.
Oh, shit. You're right,
Hit the box.
Son of a nutcracker.
So all you do is just plug it into the phone line.
Yep.
For these?
Mm-hmm.
So nothing else. It's like a free response too.
It would be just like that. Okay? That's it.
Oh my god. That's great.
Okay. Looking at number 3. I'm assuming I'm going in order, right? Okay. So it says that we have to find negative 2 times vector u and add that to 4 times vector v. Okay? So I'm going to first find negative 2 times vector u. Okay? So I'm going to take negative 2 and multiply it by those 2 components. So what 2 numbers would I get? Negative 8 and what? 2. And then if I do 4 times vector v, what do I get for 4 times these 2 numbers? 20, right? Okay. Then I have to add these 2 vectors together. So we remember you add the components together. Okay? So we're going to add negative 8 and negative 12 together, and what do we get? Negative 20. And then we're going to add the 2 plus the 20. What do we get? All right. Number 4 says use that same vector. Well, basically, we're going to use this answer and then find the magnitude. So remember, the magnitude is you take each of these components and you square them. And then you take the square root of the whole thing. I don't know what number that comes out to be. You can use a calculator on that part, yeah. I haven't decided yet. I'll let you know tomorrow when I look at the test. Is it 26? Comes out nice.
Yeah, bro.
All right. Do you want me to do number 5?
Can you hold on really quick?
Yep.
Oh yeah, it's 29.6.
I'm good.
It's 29 point what?
Oh,
732.
Good job.
Good job. Appreciate you.
Should we just make Devin speak?
All right, we good with 4?
I am good.
All right. What do I need to do to get velocity?
Derivative.
Derivative. Okay, so what's the derivative of sine 4t?
Cosine, or 1/4 cosine of 4t.
Okay, so derivative of sine is cosine. What's the derivative of 4t?
1/4 or 4.
4. All right, what's the derivative of cosine?
Wait, but don't you have to pull it out 1/4?
No, that we're not doing a u sub. Okay.
Oh.
It's just a straight derivative, right? And then derivative, and there's no chain rule on that one. All right, acceleration vector. Derivative again of the velocity, right? So what's the derivative of 4 or cosine 4t? Negative sine 4t. And then the derivative of the 4t part is what? Yeah, you're going to put a 16 in front. That's good. All right, what's the derivative of negative 4 sine t?
-4.
Good. All right, we good with 5? All right, number 6. A particle moves on a curve, y equals the natural log of x, so that its component has this derivative. So they gave us the derivative of the x component. At time t equals 0, the particle is at the point 1, 0. So at this time, at 0 time, the particle's already moved a little bit. Find the position of the particle at time t equals 1. So right now I have the derivative. How do I get to position? I have to integrate. Okay. So when I integrate x prime of t, and I'm integrating the t plus 1 dt. All right, so when I integrate x prime, what do we get to?
X.
X, right? X of t. And then when I integrate t plus 1, I get?
T squared over 2 plus T.
Plus
D. Oh, I don't know, C or something?
c. Now, I have not used this initial condition yet, right? That's what I'm going to plug in for
T.
this. Okay, so what goes in for the t value?
0.
0's going to go in for the t value. What's going to go in for x of t? 1. The x part of that, a part of that vector there, or that point. So you're going to get 1. Hold on. Oh, yeah, 1. Okay. So what does that mean c is going to equal? 1. Now, it's not, it hasn't, we haven't finished yet. We have to find the position at time 1. So I need to rewrite this equation. So x of t equals t squared over 2 plus t plus 1. And then what am I supposed to plug into it? Yep, 1. So 1 squared is 1, so 1/2 plus 1 plus 1. And that gets me either 2.5 or 5/2, right? It wants the actual position, so it might come up as a point. Okay. Notice they gave you the y right there. So to get the y value of the point, you would do y equals the natural log of 5/2. So the point would be 5/2 natural log of 5/2. I don't know. But I was waiting for you to complain, because I knew it would happen. I think you'll be okay.
Miss Ballard? So when we integrate, like why don't we integrate from 0 to 1? Because we have that point or the time t 0 and t1.
Why didn't we you put a limit on our integral? because they didn't give me an interval. Because remember, this is an x value and this is a y value. They're not the same value. Okay. If they give you an interval of some kind in there, then you know you're gonna do direct or whatchamacallit.
Apple skin?
You're not gonna plug that in. Is it similar and I told you to do something different?
And you told us to do, like, what's it called?
Definite integral?
With the,
Yeah, I don't know.
that is kind of weird, actually.
Maybe I must have been wrong.
And we were so confused.
I'm sorry. Are you now confused? Are we unconfused now?
Yes.
Okay. All right. That was my fault. I'm sorry. Okay, we good with 6?
Yeah.
Okay. Let's look at 7. So for what values of t does the curve given by the parametric equation have a vertical tangent? Okay. So if we're going to do a vertical tangent, well, they gave us first. We do need a derivative. Okay. So we know dy dx is really dy dt over dx dt, right? And to get a vertical tangent, does that have to do with the y component or the x component? Yeah, it has to do with the denominator. So if it's a vertical tangent, I really want the denominator to be equal to 0. So what I'm going to do is I'm just going to take the derivative of this one and set it equal to 0. So dx dt equals, so what's the derivative of this x equals here?
3t squared minus 2t.
Okay, and we're going to set it equal to 0. What's your greatest common factor? And we're left with
3t minus 2.
good. And so we've got t equal to 0 and t equal to 2/3. So for what values? I guess it says values, so you could use them both.
That's the answer?
That's the answer. You'd use the other one, yes.
You use y for horizontal?
Correct. All right, we go with number 7.
That is scary, dude.
Is it really that serious?
How is it offensive?
All right.
Yeah.
A particle moves in the xy plane. Shh. You're listening.
It's pretty crazy.
Because I don't have to do over this. I can just give you the test. All right. A particle moves in the xy plane so that its position at any time t is given by this function and this. What is the speed of the particle when t is equal to 3? So remember, speed is the same as magnitude. Okay. All right. Okay, so speed is the same as magnitude. So we're going to take the square root of the derivatives of the function. Okay? So what's the derivative of the x component? Negative sign, I like that. Okay, I got to put a 5 in front, and then I'm supposed to square it. And then plus, what's the derivative of the y component? 3t squared squared. And then to get the speed at a very specific time, what am I going to do with that 3? You're going to plug it in. Okay? So negative 5 sine of 15, right? I'm plugging in a 3. Plus 3 squared is 9 times 3 is 27, right? I don't have an answer for that one, so you have to let me know what it is.
I know.
I don't know what you did. Did you plug in 3?
Yeah, I don't know what the answer is.
Can we leave like that?
You technically you have to take the sign. You can't leave the sign unevaluated.
But what if it's for your response?
Even on for your response, you have to evaluate the trig piece.
No.
26.96.
26.96. Is there another number after it?
0.
0. Okay. Doesn't hurt to write the 0 because we've got to go 3 decimal places, right? All right, we good with 8?
Yes.
All right, number 9. Okay, the position of any particle at time t greater than 0 is given by this. Okay, we need to find the magnitude of the velocity vector at time t equals 2. So that means I need to take some derivatives. Okay. So what's the derivative of the x component?
Two.
2t, and then I square it because we're looking at magnitude. Plus, what's the derivative of the y component? Well, the 3 is going to go in front, right? What's going to happen with the 3's? It'd be 2t squared squared. Okay, and then what are we going to do with this 2 that's right here for the t? Plug it in. So let's see, 2 times 2 is 4 squared is 16, right?
Sure.
And then 2 times 2 squared is 4 times 2 is 8. Squared would be...
64.
So it's whatever the square root of 80 equals. And square root of 80 is a fine answer.
Is a what?
It's a fine answer. It's a good answer.
Oh. I was like, finance or like money?
No. Fine answer. Fine answer, not fine answer. All right. Part B. We are supposed to set up an integral expression to find the total distance traveled. Okay, and notice it says integral expression, it says set up, we don't have to evaluate it. Total distance traveled by the particle from 0 to 4. So there's an interval, that's what's going to go on here. Okay? All right, to get total distance traveled, we integrate the magnitude. So you're going to integrate basically this thing right here. 2t squared plus 2t squared. You could probably simplify it more, but that all you had to do is show me the setup. You could. All right.
Wait,
Yes.
so you plugged in the magnitude? Wait, what did you...
Total distance is the integral of the magnitude.
Okay.
Okay. All right. The next thing we're supposed to do is find dy dx as a function of x. So dy dx is the same as saying dy dt over dx dt. Okay. All right, so dy dt is just this piece right here, isn't it? 2t squared. And dx dt was the first chunk, 2t. So I could evaluate that just down to t, couldn't I? Oh, but then we've got to write it as a function of x. Is it a function of x right now? Not so much. It says t. So what I have to do is I would probably solve this for t up here, okay? So it's right now I would just consider that as an x equal. So how do I get the 2 to the other side? We're going to add it. So I'm adding my 2. And then how do I get t by itself? Square root. So t equals the square root of x plus 2. So this one here would be t as a function of x. If they asked me for a function of y, I would use the other one. All right. The next one you're going to want to know probably what the picture looks like. Okay? So we need to find the area of the interior. So either I will have the picture there for you, or you'll get to use your calculator to find the picture. Okay? I haven't decided how much is going to be calculator and how much is going to be non-calculator. Probably not. Okay. All right, so let's put that one in together. I'm going to get rid of what's there.
We skipped D for 9.
Did we skip B for 9?
Yeah,
D?
D.
Oh, was there a D?
Yes, what time T is a particle on the y-axis? Find the acceleration vector at this time.
Sorry. I apparently didn't have that part up here. All right. So part D said what?
At what time T is the particle on the y-axis? Find the acceleration vector at this time.
Find the acceleration vector at that time. Okay, so if we're looking at the time that it's on the y-axis, that means we want the y-axis to be equal to 0, right? So wouldn't I take this, set it equal to 0? That might not work, will it? I got t cubed equals, oh it will. When I multiply that over, no, it's 0. It turns out to be 0, doesn't it? That doesn't seem right to me. There's something wrong with it. I need to go back and look at that one, okay? I'll try to remember to figure that one out before tomorrow, okay? So I need to, it was number 9D. Okay. Sorry, for some reason I don't have an answer to that one. Okay. Let's look at number 10. We're going to go ahead and put this in the calculator, okay? So everybody's putting this in with me because you have to be able to do this on your own on the test. I can't enter that. I want to use my polar mode. So menu, graph, edit, entry, and I want to switch to polar.
Polar.
And then it's 1 minus sine of theta. And theta is hiding under the pi button there. And hit enter.
Where's Waldo? I saw him.
I'm going to go ahead and I'm going to blow it up a little bit here. Alright, I'm going to sketch that picture. If I were you, I would probably sketch it into what I'm studying just so I knew what it looked like. Okay. Alright, so here's how I'm going to find the area of this. Okay, it said it wanted the area of the interior, right? Well, the interior is the whole thing, isn't it? I'm not going to try to integrate the whole thing. I'm going to just integrate half of it and multiply by 2. So whatever I integrate, I'm going to multiply by 2. Okay? So there's a couple of ways to look at the limits. All right? We're supposed to find the area of the interior when... for this, I want to know where it is equal to 0, probably. So that means I've got negative sine theta equals -1, and sine theta equals 1. We know that that happens at, not pi over 2, right? But in order to get this chunk of it here, if I just use the graph to find my limits, I would go from negative pi over 2 to pi over 2. And remember, you want it to be a continuous radian measure when you're integrating. That's why we didn't use 3 pi over 2. All right, and then I'm just going to go ahead and integrate this guy the way it looks. 1 plus sine theta. Oh, sorry, 1 minus sine theta. Were we supposed to square it? I don't remember. I think we were. I think I have the wrong answer written down. Let me make sure. I think mine's wrong. Yeah. Correct. You'd set them equal to each other to find... That is great. Yeah, we do have to square it. Okay, my answer's wrong. Okay, so we're gonna go with what we're gonna do it the right way, and hopefully we can get the right answer at the end. Okay. All right. So we've got 2. I want to FOIL this thing. Okay, and remember this is where we have to use half angle and stuff. So we've got 1 minus 2 sine theta plus sine squared theta, d theta. Okay.
You're supposed to end at 12:03.
Anna, this is for you. Since you have your donut. All right.
I thought you put it 1/2.
What?
I thought you put it 1/2 in front of it.
Do we need a 1/2 in front of it? Probably. I didn't look up the formula, but this is one we didn't end up doing last year. Let's see. All right. Cora's right. We need to put a 1/2 in front. So if I'm doubling it, I'm putting a 1/2 in front, doesn't that just go down to a 1?
Yeah.
Okay. So now let's see what we can do to integrate. I think I have to do a power reducing on this thing, don't I?
I think so.
Yeah. Let's put the power reducing in there. I think we have to make it a sine, don't we? Or a cosine.
Yeah, I think so.
Okay, so what I will do is I will make sure your trig table is available for you for the test. Okay? In case you need it. So if we're going to look at power reducing for sine squared. So 1 minus 2 sine theta. What's my power reducing here? Okay, you guys have the Chromebooks. You have books. Grab the table and tell me what the power reducing is. Anybody got it? Yep, take the pass. 1 minus cosine, it's not squared. Cosine 2 theta, and instead of writing 1 minus and then dividing by 2, I'm going to do this. Okay?
Oh, no.
All right, so what is, let's see, this would be 2/2. What's 2/2 plus 1/2? So what do we end up with 2/2 plus 1/2, guys? 3/2 minus 2 sine theta. That's okay to have an improper fraction. 1/2 cosine 2 theta d theta. All right. So before I integrate this back piece, all right, I would probably want to look at the u on that. So my u would be 2 theta, wouldn't it?
Yes.
So du is 2 d theta.
1/2.
So I need to put a 1/2 in there, which means I'm really making this 1/4. Now I'm ready to integrate. So when we integrate 3/2, what do we get?
3/2 theta.
3/2 theta. When we integrate sine, what do we get?
Cosine.
Shouldn't it be negative cosine?
Negative cosine.
So that's going to go positive. And when we integrate cosine, we get
Sine.
sine. And then we're going from negative pi over 2 to pi over 2. All right, I'm going to see if I can squish my final answer into this little chunk right here. Okay? So 3 pi over 2, or 3 over 2, not 3 pi over 2. All right, so 3 over 2 times pi over 2, plus 2. What's the cosine of pi over 2?
0.
It's 0, isn't it? Okay, so that's going to go away. Minus 1/4. What's the sine of, let's see, when I put 2 theta
Pi.
of pi, what's the sine of pi?
0.
Also 0, so that's going to go away. Okay? Minus 3/2 times negative pi over 2. And then I need to do the cosine of negative pi over 2 is still 0, isn't it? And the sine of negative pi is also 0, so that goes away. So it looks like I've got 3 pi over 4 minus negative 3 pi over 4. So 6 pi over 4 or 3 pi over 2. Do we agree? Yeah? My answer was nowhere close to that. So if you do it wrong, it will not work. All right, we good with 10? All right, let's look at 11. 11, I know I did correctly because I looked it up. I looked up at least I looked up the formula. All right, so for the length of the curve, all right, what do you think your limits are going to be? 0 to pi over 2. Okay. And then what we have to do here is we take the original and square it plus the derivative squared. So this is original squared, and then derivative squared. Okay? So my original is 1 plus sine theta. What's the derivative of 1 plus sine theta? Cosine theta. And we got to throw a d theta after it. Okay. So, I would probably FOIL this out. So remember, that's like 1 plus sine theta times 1 plus sine theta. We just did that in the last problem, I think. Or we did something close. So 1 plus, in the middle you'd have 2 sine theta, and sine times sine would be sine squared theta. That looks pretty bad. Plus sine squared theta. Okay. And then this thing is just going to be cosine squared theta. All right. What is sine squared plus cosine squared? It's 1, isn't it? So what's 1 plus 1? Thank you, Cora. It's 2. So I've got the square root of 2 plus 2 sine theta d theta. No, just throw it. All right. What can I factor out?
2.
I can take a 2 out, but I'm not just taking a 2 out, I'm taking out a radical 2. All right, notice I have yet to integrate anything. Okay. Now we need to look at our half angle identities. So this gets really weird. Okay. Oh, it's a sine. How did I get a... Oh, I messed up on something. All right. But I think I'd be close. All right. So do we have the... I need you guys to look in your notes real quick at the half angle. Because I don't think I have mine written down right. Are we looking in our notes for the half angles? They aren't on the trig table. So do we have the half angle for 1 plus sine theta? What is it? It's square root of something, right?
What?
Is it 1 minus? Is that right? 1 minus, is it 1 minus? Or is it 1 minus? Are we looking? I want to be right, so. I don't know. It's not on the trig, but it's in your notes. We wrote them down in this last section, last period of the notes. Is anybody looking it up, or am I done? Because I can be done right here and not go through this hard problem and then put it on the test. I just am asking you guys, look through your notes. I know somewhere we wrote down the half angle identities in the last couple of sections here. Look for the one that has arc length. We might have written them in the left-hand column somewhere. They're not in the trig table. Do we find them? Or use the internet and search half-angle identities. There's another way to do it. Yes. You want to do the... Oh, but see, it isn't the sign, is it?
Oh, that's way different.
Oh, yeah, it's way different. Okay, so I don't know what I was... I'm...
Is it the power sign?
No, because this isn't a power reducing, it's a sine, right? For some reason on mine I turned it into a cosine. I have no clue why I turned it into a cosine. Yeah. Okay, we're going to hit a pause on this one and I'll figure out... I don't have it figured out right yet. Okay? So I will have that one ready for... At least videoed for tomorrow, okay? Alright, let's look at 12. At least I know enough to know... Yeah, don't. Alright. So... What we need to do is find, we're supposed to find the area of the region, okay? One of them looks like this. This is the 1/2, I'm guessing, okay? And then one of them is the rose curve, right? All right, and what I would do with it is you have to do it. I think when you evaluated these guys here, you got pi over 6 and negative pi over 6. Do we agree with that? Okay. Or is it pi over 4? Because look at what the limits are supposed to. It says pi over 4, doesn't it? I have pi over 6 down though for some reason. All right, area of the region that lies inside the polar curves. So we're supposed to be finding, I believe it's this region and outside the circle. So it's this region right here is what we're supposed to be finding, okay? So what I ended up doing was I went from negative pi over 6 to pi over 6, which would be inside this anyways. And I did the this one first, okay? So the cosine squared 2 theta, and then I subtracted the circle out of it. So subtract the 1/2 out of it, d theta, and you got to square both of them. Okay. And then you have to multiply. You still have to do the multiply by 1/2 out front. Okay, because it's the formula. And then this you had to use a u on. Okay, does that make sense? You have to use a u on it. Devin, you gotta go. All right, is that enough on the setup, Cora, or no?
Yeah.
Or did we get confused on the other part? Okay. All right. Are there any others you want me to set up in the last 2 minutes? Or 3 minutes? I guess we get to 03. Yeah, you can check out. No, you'd have to keep going. That's just the setup. Yep. Okay, the other thing you probably want out too is your trig identities table. Okay? So we're looking at multiple choice. We're going to look at number 6 from the multiple choice. All right. Before I go ahead, I'm going to go, let's graph that in the calculator. So everybody graph number 6 in the calculator. Let's make sure you know how to do it. I'm going to get rid of what's there. And we're going to look at, it is cosine 2 theta. Oh, what did I do wrong already? I need to go into polar. So go to polar. And it is cosine, no, it's cosine 2 theta. Thank you. There's another one. Wolf is still missing too. I don't know who had wolf. 2 theta. Alright, so there's one of them. And then the other one was 1/2. Alright, and it's a good idea to probably blow that picture up a little bit, so I'd zoom in on it. Alright, if it was me and I was taking notes for my test, I'd probably go ahead and sketch that picture somewhere in there. Okay, so first of all, we have to understand what are they, what is the area they're actually asking us about. So they say inside the rose curve, right? That's the first part, is inside that curve. Why is this not in? This is acting silly. Hang on. All right, let's graph this. So they want inside the rose curve, but outside the circle. So what they're looking at are these 4 things here. Does that make sense? So I'm only going to find the area of one of them, and then I'm going to multiply that area probably by 4 at the end. Okay? Oh, but wait. What else does it tell us? I don't need to multiply by 4. What does it tell us? Yeah, so I'm only going in between here. Okay? But more specifically, I need to figure out where those points intersect. So how do I figure out the intersections? Yeah, we're going to set them equal to each other. So we're going to do cosine 2 theta equals 1/2. Where are the two places where cosine equals 1/2? Pi over 3 and 2 pi over 3. Okay, Anna, this is for you. All right. Is 2 pi over 3 on this in between negative pi over 4 and pi over 4? It's not, right? My guess, it's not, and it's not 2, it wouldn't be 2 pi over 3. Wouldn't it be down here? Shouldn't it be 5 pi over 3? Yeah, I think it's 5 pi over 3. All right, and then when I multiply by 1/2 on both of those, I get pi over 6 and 5 pi over 6. But if I'm going to translate that to being inside this interval, I would, instead of using 5 pi over 6, we would use negative pi over 6. So those are the limits. We would go from negative pi over 6 to pi over 6. Okay? Then what I have to do is let's see. It looks like it's going to be the rose curve minus this inner, because I want to get rid of this chunk in here, right? I'm trying to subtract that. So I'm going to do the rose curve. I'm going to square it. Remember, that's part of the deal. Square it minus the other curve, the circle squared, d theta. And then remember, part of the formula is we multiply by 1/2 in front. The formula is 1/2 the integral of the function squared. Okay. All right, so now the question is, how on earth do we integrate that? And you may or may not get to use your calculator. So if we get to use our calculator, great, put it in, right? And there's going to be one here that might come up in a few minutes. I'm just going to say use your calculator because it was a nasty problem, okay? But we might have to do it by hand, so let's look at doing that by hand. Don't we have double angles? Let's look at, or no, actually not double angles, power reducing. Look at the power reducing. Isn't power reducing, can't I substitute for power reducing? That's the U. So help me out with the power reducing. Over 6 to pi over 6. So what would we get in there for the power reducing? Cosine of 2u. So my u is 2 theta, so I would use 4 theta, and then it's all divided by 2, right? Instead of dividing by 2, I'm going to use 2, I'm going to split it up into 2 fractions. Okay, and then minus 1/4 because we're squaring the 1/2. All right, so before I go to integrate that, what's 1/2 minus 1/4? 1/4 plus 1/2 cosine 4 theta. All right. What about the u sub on this piece right here? My u would be 4 theta, right? So du would be 4 d theta. So d theta would be 1/4, right? So don't I have to add a 1/4 in there? So 1/2 times 1/4 would end up being what? 1/8. So I'm going to just write it as 1/8. And then we're going to just integrate it the way it looks. Okay, I'm going to try to squish it in up in this area. So we've got 1/2. When I integrate 1/4, what do we get? 1/4 theta, okay? Plus, when I integrate cosine, what do we get? Sine 4 theta. And we're going from negative pi over 6 to pi over 6. All right, so you've got 1/2. We're going to go ahead and sub in. What would 1/4 times pi over 6 be? Pi over what? 24. That's looking good, right? Look at our answers. We've got some pi over 24s in there. Might not necessarily be the answer, but it looks good. So plus 1/8 sine of 4 pi over 6. Isn't 4 pi over 6 2 pi over 3? You might need to write that out. Sine of 2 pi over 3. And then we're going to subtract, and it would be negative pi over 24 plus 1/8 sine, and it would be negative 2 pi. I'm not squishing it in well, over 3. That says negative 2 pi over 3. All right, I'm going to distribute this in. It's going to go minus, and then we're going to evaluate our numbers here, hopefully. So let's see, I've got pi over 24 and pi over 24. How many of those do we have? 2 pi over 24, right? And then 2 pi over 3. Oh, look at this. Oh, no, it's negative 2 pi over 3. We can't cancel them. So 1/8. What is the sine of 2 pi over 3? Yeah, radical 3 over 2, which is really over 16. Let's see what happens with the other half of it here. So negative 1 over, let's see, what's the sine of negative 2 pi over 3? Yeah, it's negative square root of 3 over 2, so that's going to go positive. So we've got 2 of these guys too, don't we? These would be square root of 3 over 16. So you have 1/2. It would be pi over 12 plus 2 square root of 3 over 16, which would reduce to 8, wouldn't it? And then I have to distribute the 1/2 in. So pi over 24 plus square root of 3 over 16. Square root, so it's looking like E, right? So the reason to not go on the well, I guess you could go on the calculator, couldn't you? And then just figure out all your answers on the calculator in decimal. The reason to not use the calculator, where it probably wasn't a calculator problem originally, because if you look at the answers, they're not in decimal. All right. Are there others that you guys want to talk about? 7 on the multiple choice? Okay. All right. Find the area of the region located in the first and fourth quadrant and bounded by the polar curve r equals 3 plus 2 sine theta. All right, I'd probably go ahead and graph it. So let's graph it with our calculator. And either I'll have the calculator available for you to graph it, or we'll have you, or it'll be pictured for you, okay? We'll at least do that to cut down on the time a little bit. So we need to do menu, edit entry, and do polar. And then it is 3 plus 2 sine theta. Nope, not sine of infinity. I hit the wrong button. Okay. So I'm going to copy that. I would do a sketch of it real quick. So it only wants the region that's in the first and the fourth quadrant. So I'm only finding this half of it over here. Okay? So looking at the limits that we would put on there, where is this measurement at here on the unit circle? 3 pi over 2, but that doesn't work as a continuous. So I would switch it to negative pi over 2. And then where's this measurement up here on the unit circle? Pi over 2. Remember, it has to be a continuous measurement. Okay? The formula says we have to do 1/2 from negative pi over 2 to pi over 2. Okay? And then we're going to take the function 3 plus 2 sine theta and square it, d theta. Okay, again, you could use your calculator, but all the answers are in terms of pi, so likely they didn't use their calculator, so they crunched it out by hand. Okay, so it's not a bad idea for us to do the same. So I have to FOIL this thing here in the middle, or this thing here, 2 sine theta. So let's see what happens when we FOIL from negative pi over 2 to pi over 2. All right, so what's 3 times 3? 9. And then 3 times 2 would be what? 6, and we've got 2 of them, so 12 sine theta. And then 2 sine theta times 2 sine theta is 4 sine squared theta. And then we've got a d theta after it. Alright. Probably what I would do now is for this piece here, we need to put in the power reducing again, right? Pi over 2 to pi over 2. So we've got 9 plus 12 sine theta. So the power reducing on that is going to be what? 1 minus cosine 2 theta over 2, right? The 2 could cancel into the 4 how many times? 2. So I'm going to rewrite that just a little bit before I try to integrate it. Actually, I'm going to do some combining and writing at the same time here. Okay, so when I distribute that in, what's 2 times 1? 2 plus that 9 is what? 11 plus 12 sine theta minus 2 cosine 2 theta d theta. All right, before I go any further, let's do our u substitution. My u would be 2 theta, right? So du is 2 d theta. So you have 1/2 du equals d theta. So I need to add a 1/2 in here, so what's going to happen to the front? There's going to be a 1, right? Okay, so I'm going to try to squish it in right here. So we've got 1/2. When I integrate 11, what do we get? 11 theta. Or when we integrate 12 sine theta, what do we get? Negative 12 cosine theta, good. And then when I integrate cosine theta, what do we get? Negative, it'd be negative sine because we have a negative here, right? Sine 2 theta. And that goes from negative pi over 2 to pi over 2. All right, so I've got 1/2. I'm putting in the pi over 2, so I would get 11 pi over 2 minus, what's the cosine of pi over 2? 0, so I'm not even going to write it down. What's the sine of, it looks like pi? 0, so that these two are going to go away, okay? So minus, and I put the parentheses, it would be a negative 11 pi over 2. Cosine of negative pi over 2 is what? 0, and then this would be sine of negative pi, which is 0 again, isn't it? So that's going to go positive. So let's see, we have 1/2 times, is it 22 pi over 2? So let's see, if I multiply across, it would be, let's see, 2 goes into 22 how many times? 11, so my final answer is 11 pi over 2. Is that one of our choices? Yay. It's always good when we get one of the answers, right? Okay, what else do we need to talk about? Which one? You want to go do it? You want to do 8?
Yeah.
Okay. All right, we got to find the length of the polar curve. Okay. The length of the curve, remember, is we take the, you got to integrate it, so it'd be integral of wherever to wherever, and you take the function squared minus its derivative squared. Okay, that's the formula, you got to know that. All right. So my function is e to the theta. So we're going to integrate from 0 to 2 pi. So the function is e to the theta, and when we square it, it would be e to the 2 theta. What's the derivative of e to the theta? E to the theta, right? So it would be e to the, and square the derivative 2 theta. So e to the 2 theta plus e to the 2 theta is what? What's wrong? Oh, it should be minus, you're right. Oh, wait a minute, we need to look that up. Let's look it up real quick. So I have, oh, it's plus, it's not minus. Nope, that's revolution, sorry. Hold on. No, it's plus, I'm wrong. This is wrong, it's plus. Okay? Everybody good? So 2e, I'm going to rewrite this a little bit different. E to the theta squared. It means the same thing. Why was it good to write it like that? Yeah, I can cancel the square and the square root. So I'm just going to throw the square root of 2 out front because it's a constant. The square and the square root cancel, so I just get e to the theta d theta. We like integrating that. When we integrate e to the theta, what do we end up with? E to the theta from 0 to 2 pi. So let's see, I've got the square root of 2 times e to the 2 pi minus e to the 0 power. What's anything to the 0 power? 1. So I distribute the square root of 2 in. Oh, I don't need to distribute the square root of 2 in, do I? Look at the answers. It looks like D, doesn't it? That's actually a nice problem. For it being a hard problem, it's a nice problem. All right. What else do we need to talk about? 9 on the free response, or on the study guide? Oh, 9 on the multiple choice. Multiple choice, okay. So we need to find the length of the polar curve, and then when it says length, it means the arc length, okay? They gave us the curve. They said that we're going from 0 to pi, okay? So remember again, it is the function squared minus the derivative of the function squared, okay? So I know I'm going from 0 to pi. I'm going to do the square root of sine theta minus cosine theta squared plus the derivative. So what's the derivative of sine? Cosine theta. What's the derivative of negative cosine? Positive sine theta squared d theta. Okay. It looks like I'm going to have to FOIL both of those. Okay, so let's try foiling. Let's see if we can do the FOIL without me writing it down. So FOIL would be, first would be our outside. So sine times sine would be what? Sine squared. So sine squared theta. Sine times the negative cosine in the inside would be, yeah, negative cosine sine, which I'm going to have 2 of those, right? So negative 2 sine theta cosine theta. And then negative cosine times negative cosine is going to be what? Cosine squared theta. All right, then I'm going to FOIL this one here. So cosine times cosine is cosine squared theta. Cosine times sine would be cosine sine or sine cosine, and how many of those am I going to have? 2, and I'm going to write it as sine theta cosine theta. I'm doing that on purpose. And then sine times sine is going to be sine squared theta, d theta. What is sine squared plus cosine squared? 1, and don't I have that in there twice? So doesn't that become 2? And then what do you notice about this piece and this piece? They cancel, don't they? So I'm just left with the square root of 2 d theta. So don't I get the square root of 2 theta from 0 to pi? So let's see, when I put that in, I get square root of 2 pi. Again, that's a nice problem. For it being ugly, looking really ugly, it's actually a pretty nice problem. All right, what else do you guys want to talk about? Number 2 on the study guide or the multiple choice? Multiple choice? Okay. Yep, take the pass. All right. All right, so number 2 on the multiple choice, we've got the function. It defines an object moving in a plane. What is the vector t tangent to the path of the object at time t equals 2? So to do this, we need to do the derivative over the magnitude. Remember, the absolute value bars mean magnitude. So I basically take the derivative of the function because it wants the vector tangent. Tangent always indicates a derivative, right? So let's start by taking the derivative of the original here. What's the derivative of our vector there? 3t squared and 4t. And then we got to do the magnitude underneath. And remember, the magnitude is... Oh, we have to evaluate, apparently. The magnitude is the derivative squared, right? And then we add them together. So now what do we have to plug in? A 2. So let's see. 2 squared is 4 times 3 is what? 12. And then 4 times 2 is 8. And then I just throw the same denominator under both of them. So when I have to put in a 2. 2 squared is, that's 12, isn't it? Plus, oh, so wait, 12 squared. I missed the squared on it, didn't I? So 12 squared is 144, right? Plus, what do we get there? 64, right? So what's 12 plus 64? 2 what? 208. All right, we need to break it down because look at your answer choices. What are our guesses that could go in the second square root box? It's either 3 or 13. Let's try 13. How many times does 13 go into 208? You guys have calculators. $16. So it would be 4 square root of 13 under here. So see, 4 goes into 12 how many times? 3. And 4 goes into 8 how many times? 2. So 2 over square root of 13. All right. What else do we need to talk about? Are there any others that you guys want to talk about? 6 on the study guide? Okay. All right. Let me find it here. Okay, so we've got a particle moves along this curve so that its x component has this derivative, okay? At time t equals 0, the particle is at this point. We need to find the position of the particle at time t equals 1. So if I'm going to find a position, I need to, from this here, if I'm going to find a position, what do I have to do? I got to integrate it. So I'm integrating the derivative equals the integral of the t plus 1 dt. All right, so when I integrate x prime, I get x. When I integrate t plus 1, I get what? Plus t plus what? C. Okay. Now, I need to use this initial condition somehow. That's how I'm going to solve for C. So at time t equals 0, the point is, my x value is what? 1. So for this x value, I'm going to put in 1. For my t's, I'm going to put in 0. So what's C equal to? 1. Okay. And then I have, so my function... x of t equals t squared over 2 plus t plus 1. And then what am I supposed to do? Plug in a 1, and that's going to get me my x value. Okay, so x equals 1/2 plus 1 plus 1. So x is 5/2. You're going to need a point, though. Do we have a way to get a y value? Yeah, we got to plug into that. So y equals the natural log of 5/2. So the point you'd be looking at would be 5/2 natural log of 5/2. Yep. All right, what else do you guys want to talk about?
Can we do number 1 on the study guide?
Yep, we can do number 1 on the study guide. All I'm going to do is the magnitude. I'm not going to worry about the direction angle. Okay? So we're going to get rid of direction angle. Let's just talk magnitude. So magnitude of the vector. Okay, remember I take the square root, and I already have the components evaluated, right? So I take the square root and I square both of those things. So the square and the square root cancel, right? So don't I get 2 plus 2, which is 4, which is, well, not square root of 2, just 2. All right, are there others that we need to talk about? Number which one? 10? 2. Okay. So on this one here, remember, the way I think about these is that cosine is my x coordinate and sine is my y coordinate on the unit circle, right? So to find the component form, you do whatever the number is, goes in front, and then you do cosine for the x component, sine for the y component, and then put your degree or radian measure after it. And that's it. That's the answer. You want to do 4? Sure. All right. So number 4. Actually, have you guys done? Do you have the answer to number 3?
No.
Do you want me to do that one real quick?
Yeah.
Because we need number 3's answer in order to do number 4. Okay. All right. So, what I need to do, remember, is I need to take, this says multiply the u vector by -2. So -2u is, I just multiply each one of the components. So what do I get for that vector? -8, 2. And then 4 times v is what? -12, 20. And then it says to add those two things up. So -2u plus 4v, I'm adding component-wise. So -8 and -12 is what? Good. And then 2 and 20 is what? 22. And then to do the magnitude, I take the square root of each one of those components and squared. So -20 squared plus 22 squared, and then I don't know what that comes out to be. I don't remember what they told me last period. All right, what else do you guys want to talk about?
Number 5.
Number 5 on the study guide?
Yeah.
All right, so number 5 on the study guide, we just have to take the derivatives, don't we? So the velocity is the derivative of position. So what's the derivative of sine of 4t? Derivative of sine is cosine, and then the chain rule gives me a 4 out front. And then what's the derivative of 4 cosine t? -4 sine t. And to do the acceleration, we take the derivative of the velocity. So what's the derivative of cosine? Negative sine, and then the chain rule is going to make it what out front? 16, good. And then the derivative of -4 sine t is? Yep, you're going to keep the sine. We hope for that one, right? That one's pretty easy. All right, what else? 7? Okay. So we're given the parametric equations. We're talking about a vertical tangent. So dy dx is the derivative of the slope of a tangent line, right? So in our world right now, that would be dy dt over dx dt. Vertical means my denominator is undefined, right? So in order to find a vertical tangent, I need to know what makes the denominator equal to 0. So that means I need to take the derivative of the x component and set it equal to 0 to figure out the times. Okay? So dx dt equals what? Minus 2t, we set that equal to 0. What's your greatest common factor? T. What's left behind? Good. And then when I solve that, t equals what two things? 0 and 2/3. All right, what else? 8. Okay. Speed is magnitude, right? It says speed here. So your magnitude would be the derivatives of these guys squared and added together. So what's the derivative of cosine of 5t? And then chain rule gives you what out front? 5. And then the derivative of t cubed is? 3t squared squared. And then it says I have to plug in a what? 3. So whatever you get in the calculator, sine of what? 15 squared plus 927 squared. I don't know what the answer is. I don't have that part written. All right, what else do we want to talk about? Which one? 9. Okay, I'm going to do parts A through C, okay? For some reason my D's not on here and I need to look up D, how to do it. All right, so if we have to start by finding the magnitude. So again, the magnitude, I take the derivative of each one and I square them. And I add it together. So what's the derivative of the x component? 2t. What's the derivative of the y component? We're going to take that 3, put it out front. 2t squared. Okay, and then I'm supposed to plug in what number? 2. So let's see, 2 times 2 is 4, squared is 16. 4 times 2 is 8, squared is, so the square root of 80. You could leave it like that. If you really want to find the decimal, you can. All they want me to do on part B is set up an integral expression. We need to find the total distance. Total distance is the integral of your magnitude. Okay, so all I'm going to do is take this magnitude that I figured out and take the integral. What are my limits going to be? 0 to 4. And you guys, there's some of this stuff that it's way complicated to integrate. All I care about is on some of it that you can set it up. Okay? All right, part C. It says we got to find the dy dx as a function of x. So I'm really looking for dy dt over dx dt, which I already have, don't I? Isn't it these guys here? This is dy and this is dx. So 2t squared over 2t, which what does that reduce to? T. But here's the problem. They wanted it as a function of x. So what I have to do is I have to go back up here and solve this thing for x. So, I'm sorry, for t. So what do I do to move the 2? Add it. So x plus 2 equals t squared. And then how do I undo this squared? Square root x plus 2. So that's it as a function of x. All right, what else do you guys want to talk about? Which one? 10. Okay. 10. Let's see if I have another. Let me find what I did. Oh, I know. This is the ugly one. Okay. So we're going to set this one up. We are not going to try to integrate it by hand. Okay? Okay, that's fine. Yeah. Okay. So looking at 10, let's get it in the calculator. So everybody put that in and let's get a picture of it. Okay? Yeah. Yep, take the pass. It wasn't minus, it was plus, wasn't it? I put a minus. Oh no, it is minus. Okay. Yeah, it's the clock's way off. And then, yeah. And this period is a couple minutes longer. Okay. So we need to find the area of the interior of this. So here's what I would do with this, okay? It is really, really ugly. So again, we're going to use our calculator to do this for us. I guess that was just the length. So the first thing I need to do is decide, I'm probably only going to integrate half of it. I'm going to just integrate that half. So what would I start at? Yeah, negative pi over 2, and then what would I end at? Pi over 2. Okay, and remember the formula is 1/2 the limits, and then you take the function and you square it d theta. Okay, so what I'd probably look for on this one is, can you set it up? And then at that point, would you be able to put it in your calculator and get the area? Oh, this was 1/2 was the formula. If I want the whole area, what do I really need to do to this thing? I need to multiply it by 2. So really, I'm just going to integrate the way it looks. Okay? So I'd say put it in your calculator. When I tried to do it, if you watched the video for the 4th period, I tried to do it by hand, and we ran into an issue with sign that I was having trouble with. So that's why I'm saying use your calculator. Okay? All right. Are there any others that you guys want to go over today? 11. Okay. All right. So 11, we would need to find the length of the curve. Okay. And again, I think we're going to use our calculator to help us out here. Okay. In fact, this is one that Marlette tried in the homework, and we have it all written out, but again, I'd probably use my calculator to do it. It says we have 1 plus sine theta, so I could look at the picture real quick. It's going to flip this one, isn't it? That was 1 minus. So we're going to go 1 plus. Alright, so there's my picture. Okay. And it says it only wants us to go from 0 to pi over 2. So I'm really only finding this area right in here, right? But the good news is I don't have to think about the limits at all. I'm just going to put that in. And it wants the arc length. So remember, the arc length is the original squared plus its derivative squared. So what's the derivative of this thing? Cosine theta. And again, I would go ahead and use my calculator to do it. Believe it or not, the answer should be 8. Okay. All right. Are there any others that you guys want to talk about? 12. The 12 I said we were going to hold off till tomorrow. Okay? Because I need to look at it again before I try to show it to you guys. Alright, there's nothing else. Alright, so tonight, again, I'm here from 6:30 to 7:15. Please make sure if a parent is picking you up that you have them here at 7:15. Okay, so tell them we're going to be done at 7:10. Alright, so that I can get home and feed the baby. Alright, because I will be away from... yeah, that's not going to happen. I have to be at a meeting at Diamond Valley at 4:30, from 4:30 to 5:30, so... I get to see, like I said, I see you guys more than I see the baby today. Or the other two children. So. Alright. If you really want stamps, I can stamp. If not, we can do that tomorrow.